So, good afternoon, everybody. Seeing these images that you had from the crews on the International Space Station, just taking a look at those is truly one of the reasons that I work for NASA. It is just amazing. And as Aristotle said, the soul never thinks without a picture. So certainly all of those pictures give all of our souls some room for thought. And those kind of things help us to dream new dreams and actually make those dreams a reality, which is all really a part of why we're here, right? It's truly making the things that we dream come to fruition. I've worked for NASA for 28 years and have just had an amazing career. But it's truly the exciting missions that we've done have been fantastic. But I got to tell you, it's the people that keep me coming back every day. Our amazing employees, our folks that we work with in industry, our students that we work with, and some of them are here, inspire me more than anything. And it's truly the reason that NASA is successful and that we are able to accomplish the amazing things that we do. So we're going to need all of you to keep bringing that spark of innovation, the creativity to us, and be a part of this journey as we go forward. The theme of this conference is Crossroads, how our generation will take us to the space frontier. You're the ones that are going to solve the tough challenges ahead. You're the ones that are going to make that a reality. And it's truly, this conference is helping to shine the spotlight on all the places that you can contribute. And they're not, necessarily working for NASA, but working with industry, working with our commercial partners that are having all kinds of exciting days that they're starting up. There's all kinds of ways that you can contribute as we move forward in space. So just a few months ago, the world, quite frankly, held its breath as Curiosity traveled some 350 million miles to land safely on the surface of Mars. And so that spacecraft, if you heard earlier from Jody on the panel that she was on, and as she talked about, that spacecraft had to slow down from going some 13,000 miles per hour down to basically zero in about 7 minutes, and we did it. And truly, it was an amazing accomplishment. But missions like Mars Science Lab are stepping stones on this journey that we're on for exploration, and certainly on aeronautics as well. Trying to accomplish our vision, which is to reach new heights and reveal the unknown so that what we do and learn will benefit all of humankind. So NASA is truly advancing in science, technology, and exploration for economic vitality, certainly for knowledge in our nation, and to better understand and be stewards of our Earth. And that's what we're really proud to be doing, and we at NASA Langley are proud to be a key part of that. So talking a little bit more about what we're doing at the center that I'm a part of. I'm the Center Director here at NASA Langley in Hampton, Virginia, and Langley is one of 10 centers across the nation. You've already heard from Bob Cabana this morning, who heads the Kennedy Space Center and talked a lot about the future spaceport there. You'll hear from Chris Scalise, who heads the Goddard Space Flight Center tomorrow. So these 10 centers all work together, and you may hear a little duplication in some of the things that we talk about, and it's because we do different things to actually make these missions a reality. Even Jody today, when she talked about each person's calling out different things as part of the successful landing, it's because we all work together as a team to make things happen, and it takes all of the skills and the expertise to make that a reality. So we're actively working on a number of things in both aeronautics and space at Langley. We are 95 years old this year, and so many people know a lot about the Kennedy Space Center and the Johnson Space Center Mission Control, maybe even the Jet Propulsion Laboratory. But actually, NASA started at our center at NASA Langley in Hampton. It started in 1917 as the NACA. We were the first U.S. civilian laboratory. Aeronautical laboratory, and from there, a number of firsts in both aeronautics and space have occurred over this 95-year history. Actually, in a conversation I had with Neil Armstrong one time, he said, and it was truly an emotional moment, but he said, if I had to name where the most firsts in aeronautics and in aviation has occurred. It's right here. It's this place, and he was talking about NASA Langley. So we've had a huge history in aeronautics, but also space started at NASA Langley, and the Space Task Group actually started with Project Mercury there, and then actually a group went on down to form up the Johnson Space Center. So we've had a number of firsts in space from Langley as well. So we're actively working within NASA to develop the next space launch system and certainly the next crew vehicle, the Orion vehicle, that's going to take crews beyond low Earth orbit, and for the first time in over 40 years. And we're excited to be a part of that. In our history, we typically work on anything that flies through an atmosphere, so that's both aero and space. And so we're working on the Space Launch System, actually doing the aerodynamic database, the Aero database for the Space Launch System, working with the Marshall Space Flight Center. And that means we're doing different analysis, different computational fluid analysis, dynamic analysis, and also doing a lot of experimentation, doing a lot of testing in our wind tunnels, which cross all the speed regimes of flight, all the way from subsonic all the way to hypersonic. So we have large tunnels that we can actually test vehicles, different vehicle configurations within. And we're actively doing that for the Space Launch System. Other things that we're doing are actively working on the Orion vehicle itself. We're leading the launch abort system out of NASA Langley that would take the crew to safety in the event of emergency. And we're working on the landing system, leading the landing systems, and doing a number of tests over this past year. We've been doing all kinds of drop tests from our landing facility to make sure that we understand the different dynamics of vehicle entry as the vehicle is landing in the water. And so let's show you how some of that testing looks. 5, 8, 7, 6, 5, 4, 3, 2, 1, release. It'd be a bad day if the vehicle flipped over like that. 2, 1, release! So all those tests occurred in our historic landing and impact dynamics facilities that we have, a research facility, and that was actually built in the 60s for Apollo landings. And Neil Armstrong actually practiced landing on the moon there, and he told me it felt just like it felt at our landing facility. So that was pretty cool. So we're working on a number of tests and significantly less tests than we did during Apollo, because now we can simulate much more. And that actually, by doing these different tests, we help to build our analytical database that in the future we can use for development of future vehicles. This facility has also been used for land landings, and we do different crushable structures, all kinds of different materials. And we also use it for different things like helicopter crash testing and subsonic fixed wing or fixed wing type testing in this facility. So lots of things go on, and all of it is part of advancing our knowledge in aeronautics and space. At the same time, we are actively working with our commercial providers as well. It's key that commercial space transportation is successful. By enabling commercial space transportation, we're able to actually focus our resources within NASA on going beyond low Earth orbit and solving some of the key problems that we have as part of that, key challenges that we have as part of that. And so what you heard in one of the panels this morning, and I completely agree with that, is that we want to enable commercial development of space resources. Absolutely. That's part of making us successful. There's no or involved, it's an and we're doing a number of things at NASA Langley. Anytime a commercial vendor wants help or wants expertise on something, we've done a number of tests for Boeing with their capsule that they have for commercial crew. We've also tested with SpaceX in our supersonic tunnel, and we're working actively with Sierra Nevada as well on their Dream Chaser concept that they have. They're actually utilizing our HL20 design that we had a lifting body design out of NASA Langley. We've done a number of tests and have a lot of analysis and subject matter expertise on. And so we're actively working to enable the Dream Chaser to be a success as well. So it's a lot of fun, and we're really excited for the successes and the breakthroughs that are happening with our commercial space partners. So to fly a plane or launch a rocket or go to other planets, you have to go through an atmosphere. And at least for certainly most of the planets, and enable to do that, NASA Langley is always involved. So if you want to understand basically what we do in that cross, essentially we're the Aerosciences Center. So we understand this the research in flight. We're able to actually to apply that knowledge for both space and aeronautics and aviation, and so that's what we do very successfully at our center. So what enables that is the aeronautics research that we do, and I'll talk a little bit more about some of that aeronautics research that transfers to the space environment, or sometimes certainly on into aviation. The Curiosity flight you heard a lot about from Jody this morning, but what we do is we lead the entry, descent, and landing from Langley. We've been part of every successful mission, every successful landing on Mars, and we're pretty proud of that. And as you saw, it was a great team. And if I talk about what happened during that, I can talk about how complex it is and what an incredible mission that was. But quite frankly, the thing that will stick with me forever as being a highlight, and probably the biggest highlight in my career, is watching the people, watching Jody jump up and down, and watching everybody be so excited after we had such success. So again, I kind of circle back to it's the people that you don't forget, and it was an amazing accomplishment, and we were really proud to be a part of it. So what I'm giving you is the Cliff Notes version of Jody's talk this morning. So a lot went into that mission. Some of the other key things that we did as part of that mission was worked on an experiment called MEDLEY. And that experiment is called the Mars Science Entry, Descent, and Landing Experiment. And MEDLEY had instrumentation. For the first time ever, we had instrumentation as part of the aeroshell during entry. And so we were actually able to take key pressure and temperature measurements. All of those measurements are going to be really, really important for the development of future vehicles, and actually designing in less margin, which will be less cost for those vehicles as we go forward. At the same time, we're working on new kinds of technology to be able to land larger masses down to the surface, either back to the surface of our own planet or actually to other planets as well. And this is things like hypersonic inflatable aerodynamic decelerators. Get that out, or HIADs. And so we're working on key technology associated with that, and we're actually able to test some of that. It's an inflatable technology that you can utilize at hypersonic speeds, and it would actually slow the vehicle down. And it's performing quite well, and we were able to actually do a test of this on our RV3 mission that occurred, which is an inflatable re-entry vehicle that we tested out at the Wallops Flight Facility this past summer. So I got to tell you, this past summer was a pretty exciting summer. We had Mars Science Lab and our RV3 launch all within just a couple of weeks. So we had a pretty excited team with some of the successes that we had. So this technology looks quite promising. We launched on at a Wallops Flight Facility on a Black Brant 11 sounding rocket, and we were able to carry up our inflatable technology in about a 22-inch cylinder, and we went up 280 miles, which is 25 miles higher than the International Space Station. So it took us about 6 minutes to get up, and we had sure that the the inflatable surface did not, stayed inflated all the way down, which we had, as you'll see from the team in the video, we had great success. So we're pretty excited about that. And I have just, I don't have the full time that it took, but we have just an abbreviated version of that launch as well.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we have liftoff of the Black Brain 11 carrying RvesvesD. View of the rocket. Plus 40 seconds.
Now, third stage Black Brain is enabled.
Plus 50 seconds. Should be coming up on burnout.
Lantern strip.
Plus 1 minute.
Verified nose cone, micro switch.
RvesvesD is returning to Earth and descending in altitude, as you're able to see from the screen as you're watching.
And RSO ROA, have you guys entered the LEO in position?
I think the video froze up, didn't it? It's hard for me to
Process
this is
right
going
now.
off. So it was a great success, and the team was jumping up and down there in the end. I can't tell if you can see this, and up here the screen is going on and off. So, but it was very, very successful, and we're certainly going to be moving forward, even with some of our commercial partners, to look at opportunities. We have missions planned for the future that could actually bring supplies back from the International Space Station, maybe utilizing this technology. So none of NASA's missions are simple feats, and the challenges certainly involve a great community of folks. That includes some of our industry partners, as I talked about, academia as well as a key part of what we're doing moving forward, and has been, throughout our history. And also, key startup firms are all a key part of it as we're looking for some of these challenges. One of the key challenges that we have as we move forward is NASA's unmanned aircraft systems, or essentially known as UAS. So it's a global economy, and being able to increase use of our airspace, and being able to take advantage of opportunities like UAVs in the future. Certainly that is the future in aviation. There's a lot to be done there. There's a lot of challenges in air transportation to make use of our civil airspace by unmanned air vehicles a possibility. And so we're actively working through those. NASA Langley contributes with things like flight control, self-separation, damage recovery. There's a number of things that we do. And I'd like to take a moment for you to hear from one of our project folks that are talking about some of the challenge that we face in aviation, specifically in airspace, and what we're doing to try to solve them.
And this is a new frontier. These vehicles, open-ended possibilities of applications. There's many challenges with UAS in terms of being able to integrate them into the NASA. They have historically been used for military purposes. Now we're bringing them home, and the folks that make them, the manufacturers, and the people that fly them want to fly them in the National Airspace System. So we're focusing on, here at Langley, we're focusing on issues relative to separation assurance, sense and avoid interoperability. What does that mean? That means making sure these vehicles can fly safely in the National Airspace System because they have different performances. They have different ways of detecting, sensing and detecting other aircraft. So we're not looking at developing new sensors, we're looking at actually how will these vehicles operate in our NAS. And what changes, if any, do we need to develop for the algorithms to make sure that these vehicles can safely interact with the other vehicles in the National Airspace System? All these individual UAVs have been built with individual workstations. There's very little commonality across platforms. So we're looking at developing new standards, common standards for the pilots flying the these vehicles as they begin to integrate into the national airspace system. And finally, there are questions around the airworthiness. When these vehicles were built, they were built fast for military purposes. Now that they're coming home, they need to meet FAA airworthiness requirements. But what should those requirements be? Because these vehicles are different. They're smaller, they're lighter, made of different materials than our classic commercial aircraft. So what should those airworthiness standards be? And so we're helping the FAA develop those new requirements, new standards as we move forward. So for young people coming in, for students, this represents an incredible opportunity to come up with new ways, new types of automation, new types of computer software to help control these vehicles.
So unmanned systems in the future, they're going to come in all shapes and sizes, from large transport all the way down to hummingbird size aircraft. And so we have to look at the different things that they'll be used for. They can be used for anything from hovering to actually traveling in swarms. And so being able to think about that and wrap your head around that and get that working in our civil air space, there's key challenges around that. And so these missions are going to range everywhere from surveillance to actually transport of cargo around the U.S. to firefighting, to drought monitoring, to tracking insect infestation. The list is just unlimited. It's whole new markets that will be enabled by being able to work through these challenges and enable these kind of vehicles in our airspace, including my own favorite, personal air vehicles in the future. So I guess I watched the Jetsons a little too much as a kid, maybe, but I can see a future where unmanned vehicles will be utilized for that, and so we're ready to make that happen in the future. Some of the other key challenges that NASA is working on with industry is associated with reducing noise associated with sonic booms on supersonic transport. And so that's one of the key problems that we face. We have kind of unique facilities. I talked about our wind tunnel facilities that we do a lot of testing in at NASA Langley and across NASA as well. But we also have kind of a unique facility we call an interior effects room, and where we actually have human subjects, and we have speakers and such, very, very highly sensitive speakers, so we can adjust sonic boom and realize the effects on humans. And by doing that, we're actually able to characterize what's acceptable, what's not acceptable, and that helps form the basis for different vehicle configurations. And then we can actually design the vehicles with our analysis tools and create those vehicles of the future that will be able to actually be able to do overland transport, because that's the big problem that we're trying to solve, the sonic boom overland. And moving forward with that, we have computer tools along with wind tunnel testing. We have new approaches that we're utilizing there, and we're working with our industry partners on some of that. We have Boeing and Lockheed Martin partnered with us, and we have several designs in play for supersonic airliners that can carry between 30 and 80 passengers. And we can probably have these in service by 2025. So it's a pretty exciting time where we can enable new markets such as supersonic transport over land. And I want to have our project manager, Peter Cohen, who's head of our high-speed research, who will talk a lot about the challenges and what we're doing to solve those.
One of the things that has really prevented supersonic flight from becoming practical and more universal is the fact that when you fly faster than sound, the aircraft creates a sonic boom. It's a loud noise that results from the fact that the airplane is traveling faster than sound, and then its pressure disturbance is heard at the ground instantaneously. So if you look back at the Concorde and other supersonic aircraft, one of the reasons they were not successful is because sonic boom noise was so loud it's disturbing to people on the ground if heard in normal environments. So one of the major things that we're trying to do is we're trying to develop the technology that will enable an aircraft to fly over land without creating a loud sonic boom noise. We're doing that in a way that can be integrated with a practical design that is also fuel efficient and compatible with airport noise regulations and also with the environment in terms of emissions production. What we've done recently is we've learned a couple of things about how to go about designing an aircraft so that it has a sonic boom that is not, in effect, a boom. It's more of a rumbling sound. And in doing that, we've used advanced CFD tools, advanced geometry manipulation tools, and wind tunnels to explore designs that, instead of having two large shock waves, produce a ground signature with multiple smaller shock waves. But what that does is it kind of tricks the ear into hearing that the boom is not a boom, but just a series of rumbles. So we've tested that in wind tunnels. Now the next thing is to take it to flight. So the possibility of an experimental aircraft that incorporates these features, which we use to research not only were the designs successful, but how people on the ground respond to those designs. Once we get that understood, and there's the possibility to change the regulation which currently prevents supersonic flight over land, then we have to take that low boom technology and start to incorporate it into an aircraft that has other features that are very important for practical supersonic civil aircraft, such as high fuel efficiency, low takeoff and landing noise. So the next generation of going to help us to integrate all of these pieces into a design that can be built practically and open up supersonic travel to the general population, to make it widely acceptable and accessible.
So the end of the space shuttle program doesn't mean the end of NASA sending humans into space. Quite the contrary, as you heard from Peggy Whitson at lunch, there's lots going on in the International Space Station, and we have folks on the International Space Station 24/7. At the same time, we're actively working on our robust technology developments for exploration that we're going to need to actually be able to have humans do longer duration flight and actually travel to points far beyond low Earth orbit. And that's going to require a number of key things like radiation protection. We'll be able to deal with some of the extreme temperatures as well, things like lunar dust. So those kind of things, so different kinds of spacesuits are going to be key, different kind of instrumentation as well, all kinds of longer duration flight problems, and some of those are being worked on and solved as part of our International Space Station today. But certainly those technologies we're working on at NASA Langley, where we're looking at different kind of habitats and lightweight space structures, those are the kind of things that we're working on from a research perspective. In 2016, NASA will launch a spacecraft called OSIRIS-REx, and that was talked about a little bit earlier today, and I think will be talked about even more tomorrow from Chris Scalise. But our part again is returning. It's going to return samples from an asteroid, and again we're working on the entry, descent, and landing to bring those samples back to Earth, and we're actively doing the aerodynamic database and performing the trajectory analysis that would need to be would happen as part of that. So that's all things that we contribute. Why do we study asteroids? Why are we doing that? You heard a lot about that kind of in earlier panels, because they can certainly provide answers to what's happened right here on Earth. What's going on? How was our solar system formed? There's lots of answers that we can get from asteroids, and even ways to move asteroids. And some of that was discussed as well, as far as being interesting as well. So lots of things that we have to solve to travel to asteroids, just as well as to, as I talked about, for long duration flight. And those include, again, habitation, radiation protection. Probably that's one of the fundamental challenges that we face. And we're actively working on active and passive radiation protection techniques at Langley, as well as characterizing radiation. Those are some of the advanced things that we're working on for space. Mars has similar challenges as going to an asteroid, and those challenges, it takes about 6 months to get there, as you guys know. If you want to, you'd have to leave within 30 days from the surface. Otherwise, you would have to stay there 500 days due to various flight trajectory issues. And so we have to overcome some of the health challenges associated with that, and anything from bone loss, and I talked about radiation as well. So lots of things to work on, lots of challenges, lots of things for you guys to have fun and solve, help to be a part of and solve. So some of the things that we're working on, I'd like you to hear about those from Pat Troutman at NASA Langley.
My job is to figure out what the next step in human missions are for NASA. So we went to the moon, we've spent a long time in low Earth orbit on the International Space Station. And the next question is, where do humans go next? So the answer is beyond low Earth orbit. There's lots of challenges with going beyond Earth orbit. We've been going to the space station via the space shuttle and the Russian Soyuz vehicle for over a decade now. And it's close. It's only minutes away to get up there and minutes to get back. It's protected by the magnetic shield of the Earth. So when you start going away from Earth, there's a time component and there's a radiation component. Deep space is loaded with very terrible radiation. There's a long-term galactic radiation, we call it, that slowly bombards your body with particles that tend to cause cancer and other illnesses to develop. And then there's bursts of solar storms that can come in rapidly and make you heal very fast. So we have to protect those two types of radiation when we're not in low Earth orbit. The long-term radiation is a problem. We don't have to solve that yet unless we put massive amounts of very thick shielding on it. Of course, if we did that, then we couldn't push the spacecraft from point A to B. So we don't do that. So one thing we look at is minimizing the time that people are actually in that dangerous environment, which means faster, more capable spaceships. So that's the one area we have to invest in, is an advanced propulsion to get us from point A to point B. Right now, we think a combination of advanced propulsion and shielding regimes, sleeping in more protected environments, and possibly more tolerance to worse risk will allow us to make those missions happen. When we get to Mars, that's another question, because those are 2 to 3 to 5 years sometimes in duration, depending on what class we do. And we have no answers for that. At NASA Langley, we work advanced composite structures. And this attacks one of those problems, which is the mass, the weight of the spacecraft. We can make it lighter, more efficient, there's less to push, or we can push it faster. So making things out of advanced materials, whether it be the habitats or the landers, is going to get us closer to Mars. Another thing we're looking at is advanced concepts for habitation units, whether built out of composites or out of aluminum. How you place where the crew works, where they sleep, how the logistics, supplies, food and water are stored around them makes a big difference in the radiation that they get from the galactic environment. When we send people, we can't send them down on 1-ton car-sized landers. They're going to be 20 tons. So we have to go up basically an order of magnitude in capability. And right now we're not sure we know how to do that. So that's what Langley's pioneering now, is understanding the interaction between the landing systems and how you get the crew safely to the surface.
So as I wrap up, I think I would like to leave you with a couple of thoughts as you're thinking about your careers and what things you want to delve into as you talk about space exploration or other things that maybe branches, that maybe sparks that come to your mind as you experience things at this conference or elsewhere, is fundamentally is something that drives me, and that's we need something to be a part of. We need something to believe in, and we need something that is bigger than ourselves. And that's fundamentally what drives me, and I think what drives many of us. Fortunately, as you think about kind of what our country was founded on, it was founded on personal freedom. And when you think about the things that we're working on, what could be more synonymous with personal freedom than mobility? And when you think of aircraft and aviation, that is mobility. And so the things that we're working on is enabling the things that are, quite frankly, the foundations of our nation. Aviation, personal mobility. What could be more compelling than the searching for the origins of our universe? It's just incredibly inspiring, and it's amazing to be a part of something so big, so much bigger than any of us. So I want to say a couple of things. As you think about moving on and being leaders out there, I want to stress that leadership is a continual process. It's a destination. I mean, it's not a destination, it's a journey. I said it exactly backwards. It's a journey along the way, and I continue to learn as the leader of the Langley Research Center each and every day, and that's something that you need to remember. It's not the technical things that really cause us the biggest issues when we're working on any of these missions. It's really the relationships along the way, and so those are fundamentally what you need to think about as you're developing yourself. Don't just think about the technical pieces, but think about some key aspects of yourself. So 2 points on that. I mean, there's lots to talk about when you talk about leadership, but 2 important aspects of this journey that I would like to just kind of bring out and leave you with. Know yourself, your strengths and weaknesses, and be conscious of your role in relationships, both good and bad. And number 2, there is no way to measure just how valuable a positive attitude is. As the commercial goes, it's priceless. So try to remember that as you're moving forward. Really, that's where you guys come in. You're going to be our future leaders, our engineers, our scientists, our researchers. We need engineers and scientists and all to solve some of these problems that we have, to build these new rockets, these new capsules, to advance our knowledge of our solar system. We need them to develop materials to enable deep space exploration, as we talked about, to actually solve some of the problems of our airspace and the capacity that we have of our airspace. We talk about some of these new vehicles that are coming into play. Those are key things that we have, and we're going to need all of you guys. That's the things that you guys get to be a part of and get to make a reality. So one of the nation's top priorities is to improve our competitive edge by increasing and improving the quality of our science, technology, engineering, and math workforce. And truly these STEM skills are a key part of NASA and certainly our industry partners, our commercial partners. It's fundamental. So our nation is going to need to recruit, graduate, and retain 1 million STEM students over the next decade. I see that myself at NASA Langley, probably within the next 5 years. 50% of our workforce can retire. That's a pretty big challenge. That's one of those things that keep me up at night. That's why we utilize student programs so strongly, to make sure that we're getting the next folks in and being able to hire them in as part of our workforce. And so we have some 250 students at NASA Langley as part of with us annually, and we're really proud of that. That actually revitalizes all of us. It's so exciting to have students as part of it, but it actually is enabling our future workforce. So you're going to be that workforce. Each of you has the potential to become the heartbeat that makes NASA so unique. It's people, and that's how I started, and truly that's where I'll end. This is an exciting time to be a part and to enter into these fields. There's lots of exciting things going on that you're hearing all over this conference. Your passion, your drive, your commitment, your learning to make a difference gives me hope that the future of aerospace exploration is in good hands. And so I leave you with a quote from Walt Disney. It's quite fun to do the impossible. Look forward to seeing what you guys do for us. I think that am I supposed to finish at 2:30, or do you want me to take any questions or just finish? Did anybody have any burning questions they'd like to ask me, or doesn't even have to be burning? Any questions that you'd like to ask me? Hi. I'll kind of come over to the side. It's so hard to see. Well, I'll stay put. I'm going to break something. I'll stay put right here. When you were working at NASA Langley?
Yeah, when I was there 2 summers ago, I know they were at least tearing down the big wind tunnel, like behind the cafeteria. I was wondering how many of those are operational now. How many wind tunnels?
Yeah, absolutely. We have lots of smaller wind tunnels. We have 7 large wind tunnels. Well, I should say 7 large wind tunnel complexes, because some of them are aerothermodynamic facilities or hypersonic facilities. There's multiple wind tunnels as part of that. But we still have wind tunnels that cover all the speed regimes of flight at Langley. What you saw is the full-scale tunnel, probably on the Air Force side. That got demolished last year, I believe it was, last year. That tunnel was built in the 30s and operated for over 60, probably 70 years or so. Just incredible accomplishments. I have pictures of Wright brothers in there, others. It's just an amazing history. So the point in that is that yes, we have part of our plan forward is revitalization. Being the oldest center, being 95 years old, we have some older infrastructure there, and we have a 20-year revitalization plan as part of that. And so some things will come down as part of that. We'll actually shrink our footprint, but we're developing new facilities as part of that, which is pretty exciting. And so we're engaging our workforce to create those laboratories that are going to take us the next 95 years forward. So we're doing that right now. We're on our second building. Our third building is in work which is a big instrumentation laboratory facility. But our wind tunnels are still up and running and doing very, very well. And like I said, we have subsonic, supersonic, hypersonic facilities, and they're actively being utilized to solve some of the challenges that you saw.
Hi, Chris Lyon from University of Colorado. I was wondering if there's any unexpected results from the MSL data that you took.
If there was any unexpected results from the MSL EDL data, and I have to get Jody right here, that I'm going to give that question to. I think we had a lot more propellant than we expected when we said done. We learned some things that actually maybe the aeroshell won't need to be quite as thick for the future, but Jody, jump in there. I'm putting you on the spot. She's a lot smarter than I am.
Oh, that's actually, I mean, she captured the two main things. We had a lot of propellant left. I mean, it was actually more than we ran in our simulations and what we expected. So we have margin there, and then we also have, like Lisa was saying, a lot of margin on our TPS because our heating rates, and all of this is very preliminary. The results are still being worked, and we're still looking at the data, but our heating rates were a lot lower than what we thought they would be. So those are two huge things. The radar performed better than we assumed. We got radar lockup at a 1.5 kilometers higher altitude than we expected. So those are three of the main things that we're finding so far. A lot of the other things I mentioned in my talk, a lot of things were nominal, very nominal. So we're still learning. Stay tuned.
Yeah, but all of that will play into some of the future designs that we have, things like the HIAD that I showed, the hypersonic inflatable aerodynamic decelerator, that will play into those kind of systems going forward. And so it's really key. It's amazing that we didn't have that kind of information from earlier, and it adds risk to the mission when you start to put different kind of sensors and measures on there. So it was great that we were able to accomplish that as a team and get those key area measurements that we needed. Any other questions? Okay, it's dark. I don't see anybody. Or somebody, okay.
Hello, I got a question on what is the greatest setback at Langley? Is it funding? Is it capital? Or is it, I guess you don't got enough grants funding? Yeah,
so what's the greatest setback? Or I think you might mean that what's our biggest worry, perhaps, when you say setback? Because
well, I mean, what's slowing down the process?
The greatest thing that's slowing down the process. I think that we're really moving forward in all arenas. We, like everybody else, and Bob Cabana talked about it this morning, are worried about the budget environment. The world, or the nation, probably the world, but the nation is certainly worried about the budget environment. Sequestration is hanging out there, and a number of things. So budget cuts are a big concern moving forward, and what that will do to some of the missions that we're working on, and so those are all things that we're trying to plan around and move forward. But we have a lot of exciting work ahead. We're forging ahead, and we're trying to, like I mentioned, we're trying to do things very much more efficiently with our infrastructure, getting our costs down, having some of these. I don't know if you've heard of LEED certified, but LEED Platinum, using geothermal, solar, and all to power our facilities. And so as we're building these new laboratories and new facilities, we're incorporating those key technologies so that we can get the cost to operate those facilities down, and then tearing down some of the older, much more inefficient infrastructure that we have. And so in doing that, we're lowering our costs. We're operating at much less cost. So even as you start to get reductions like that, you're able to deal with some of those challenges better if you can get your costs down. So those are all things that we worry about. My workforce, is kind of the key workforce that we have going forward, and making sure we have people to take over as people retire and lead us for the next 95 years. That's really fundamentally the things I worry about. So we're trying to do, in the same way that we have what we call a vital plan for our infrastructure, we also have that for our workforce from a standpoint of trying to find new ways to incorporate knowledge and continual learning for our workforce moving forward, so people are always kind of out there on the cutting edge. Us being an R&D center where we're focused a lot on more advanced concepts and research, and then moving those through the full cycle into development. Those are the kind of things that we do, and so we always need to be beyond state of the art on the things that our folks are thinking about, and so we have to find ways to make sure that we have that knowledgeability within our workforce. Yes.
Hi, Lisa. Jules Feldhacker from the University of Colorado. I was just wondering what the next steps are for the IRVI project and what the timeline is looking like for putting that project into use.
Okay. And Jules was with us, I think, 2 summers ago. Is that right? Or was it last summer? 2 summers and 3 summers. So she's been able to work on some of the things that we're doing. For the next steps for IRVI, we're actively analyzing the data and planning for we're actively looking at an IRVI 4, and that, what would be the scale up, because we need a larger inflatable structure for larger masses. And so we're looking at scaling up some of those materials and looking at a potential IRVI 4 mission. At the same time, we're looking, and as I mentioned, partnering with some commercial folks to look at flying something called HART to the International Space Station, and actually being able to bring some down mass back from the International Space Station using this inflatable technology. And so that's looking very promising as well. So we have a couple of things in work, but with the key destination is to actually utilize this technology on something like a mission to Mars or a planetary mission. And so those are some things. So we've got to get kind of reduce the risk enough that a mission is going to be willing to take this technology and run. And so that's what we're doing, is reducing that risk right now. Other questions? Oh, I'm sorry, they're giving me the hook. So thank you guys for listening, and thanks for letting me be a part of this. It's a drop test from our landing facility to make sure that we understand the different dynamics at a vehicle entry as the vehicle is landing in the water. And so let's show you how some of that testing looks.
5, 8, 7, 6, 5, 4, 3, 2, 1, release.
It'd be a bad day if the vehicle flipped over like that.
2, 1, release.
So all those tests occurred in our historic landing and impact dynamics facilities that we have, a research facility, and that was actually built in the 60s for Apollo landings. And Neil Armstrong actually practiced landing on the moon there, and he told me it felt just like it felt at our landing facility. So that was pretty cool. So we're working on a number of tests and significantly less tests than we did during Apollo, because now we can simulate much more. And that actually, by doing these different tests, we help to build our analytical database that in the future we can use for development of future vehicles. This facility has also been used for land landings, and we do different crushable structures, all kinds of different materials And we also use it for different things like helicopter crash testing and subsonic fixed wing or fixed wing type testing in this facility. So, and reveal the unknown so that what we do and learn will benefit all of humankind. So NASA is truly advancing in science, technology, and exploration for economic vitality, certainly for knowledge in our nation, and to better understand and be stewards of our Earth. And that's what we're really proud to be doing, and we at NASA Langley are proud to be a key part of that. So talking a little bit more about what we're doing at the center that I'm a part of. I'm the Center Director here at NASA Langley in Hampton, Virginia, and Langley is one of 10 centers across the nation. You've already heard from Bob Cabana this morning, who heads the Kennedy Space Center and talked a lot about the future spaceport there. You'll hear from Chris Scalise, who heads the Goddard Space Flight Center tomorrow. So these 10 centers all work together, and you may hear a little duplication in some of the things that we talk about, and it's because we do different things to actually make these missions a reality. Even Jody today, when she talked about each person's calling out different things as part of the successful landing, it's because we all work together as a team to make things happen, and it takes all of the skills and the expertise to make that a reality. So we're actively working on a number of things in both aeronautics and space at Langley. We are 95 years old this year, and so many people know a lot about the Kennedy Space Center and the Johnson Space Center Mission Control, maybe even the Jet Propulsion Laboratory. But actually NASA started at our center at NASA Langley in Hampton. It started in 1917 as the NACA. We were the first U.S. civilian laboratory. Aeronautical laboratory, and from there, a number of firsts in both aeronautics and space have occurred over this 95-year history. Actually, in a conversation I had with Neil Armstrong one time, he said, and it was truly an emotional moment, but he said, if I had to name where the most firsts in aeronautics and in aviation has occurred, it's right here, it's this place, and he was talking about NASA Langley. So we've had a huge history in aeronautics, but also space started at NASA Langley, and the Space Cast group actually started with Project Mercury there, and then actually a group went on down to form up the Johnson Space Center. So we've had a number of firsts in space from Langley as well. So we're actively working within NASA to develop the next space launch system and certainly the next crew vehicle, the Orion vehicle that's going to take crews beyond low Earth orbit, and for the first time in over 40 years. And we're excited to be a part of that. In our history, we typically work on anything that flies through an atmosphere, so that's both aero and space. And so we're working on the space launch system, actually doing the aerodynamic database, the aero database for the space launch system, working with the Marshall Space Flight Center. And that means we're doing different analysis, different computational fluid analysis, dynamic analysis, and also doing a lot of experimentation, doing a lot of testing in our wind tunnels, which cross all the speed regimes of flight, all the way from subsonic all the way to hypersonic. So we have large tunnels that we can actually test vehicles, different vehicle configurations within. And we're actively doing that for the space launch system. Other things that we're doing are actively working on the Orion vehicle itself. We're leading the launch abort system out of NASA Langley that would take the crew to safety in the event of an emergency. And we're working on the landing system, leading the landing systems, and doing a number of tests over this past year. We've been doing all kinds So, good afternoon, everybody. Seeing these images that you had from the crews on the International Space Station, just taking a look at those is truly one of the reasons that I work for NASA. It is just amazing. And as Aristotle said, the soul never thinks without a picture. So certainly all of those pictures give all of our souls some room for thought. And those kind of things help us to dream new dreams and actually make those dreams a reality, which is all really a part of why we're here, right? It's truly making the things that we dream come to fruition. I've worked for NASA for 28 years and have just had an amazing career. But it's truly the exciting missions that we've done have been fantastic. But I got to tell you, it's the people that keep me coming back every day. Our amazing employees, our folks that we work with in industry, our students that we work with, and some of them are here, inspire me more than anything. And it's truly the reason that NASA is successful and that we are able to accomplish the amazing things that we do. So we're going to need all of you to keep bringing that spark of innovation, the creativity to us, and be a part of this journey as we go forward. The theme of this conference is Crossroads, how our generation will take us to the space frontier. You're the ones that are going to solve the tough challenges ahead. You're the ones that are going to make that a reality. And it's truly, this conference is helping to shine the spotlight on all the places that you can contribute. And they're not, necessarily working for NASA, but working with industry, working with our commercial partners that are having all kinds of exciting days that they're starting up. There's all kinds of ways that you can contribute as we move forward in space. So just a few months ago, the world, quite frankly, held its breath as Curiosity traveled some 350 million miles to land safely on the surface of Mars. And so that spacecraft, if you heard earlier from Jody on the panel that she was on, and as she talked about, that spacecraft had to slow down from going some 13,000 miles per hour down to basically zero in about 7 minutes, and we did it. And truly, it was an amazing accomplishment. But missions like Mars Science Lab are stepping stones on this journey that we're on for exploration, and certainly on aeronautics as well. Trying to accomplish our vision, which is to reach new heights,